What's up, everybody? Mr. Cully coming at you with another video, and I want to go over today's lesson that we did on the particle chart that we have been filling out. And so basically what we've been doing is we've been talking about atoms, and we've been getting into these subatomic particles and atoms, the neutrons, the electrons, and the protons. And what we learned today is this new notation in which we can determine the number of protons, neutrons, and electrons based on these numbers that surround the atom. So let's take a look here. Here we have a lithium atom. How do I know? Because of the abbreviation. Li stands for lithium. You can find it on the periodic table. If you have it, it is right here in the upper left-hand corner, and that is lithium. But what do these numbers that surround lithium mean? All right, let's look first at the top left corner. That's its mass number. The mass number is the number of neutrons and protons in the nucleus, okay? The number of neutrons and protons. Those make up the mass, all right? Those two particles make up the weight of it, essentially. So how heavy is lithium? It depends on how many particles are in the nucleus. Well, what's in the nucleus? The neutrons and the protons. So the mass number is the combined number of neutrons and protons in the nucleus. Down below that, you have the atomic number. That is just the number of protons, okay? The number of protons is called the atomic number because that's what determines what element we're talking about. So lithium, by definition, has 3 protons. So based on these two numbers, all right, the bottom one is the number of protons, the top one is the number of protons and neutrons. So that means that 3 of the 7 are protons, okay? 3 of the 7 in the nucleus are protons. So how many are going to be neutrons? 4. Why? Because remember, the mass number, this number tells me how many neutrons and protons I have. So if this bottom number tells me how many protons I have, then the top number is going to be, if I subtract the top number from the bottom number, I'm going to get just my number of neutrons. All right. Then we have over here is the charge. That is a 0. Okay. If it's not shown, then it's 0, but you can write a 0 if you want to. That just means it's a neutral atom overall. Well, remember, atoms are full of charged particles. Protons have a positive charge. Electrons have a negative charge. So if lithium has 3 protons, let me draw these right here. It has 3 protons, and it has an overall charge of 0, then it's going to need to have these be canceled out. So if I have 3 positive charges, I'm going to need 3 negative charges to cancel each of these guys out. So 3 negative charges, well, what particle is a negative charge? Those are my electrons. So if I'm going to have an overall charge of 0, I'm going to need the same amount of protons, which is 3, as I do electrons. So I would have to have 3 electrons to cancel out my 3 protons based on my charge. That charge tells you, okay, how many protons am I going to, or how many electrons am I going to need to cancel out my protons? And as we said before, the number of neutrons was 4. So 7 minus 3 is 4. So that is how, if I were to give you this symbol, you would be able to determine these numbers of protons, neutrons, and electrons. Let's build this atom for a second. Let's try to visualize this. So lithium, first of all, it's got 3 protons. So I'm going to go to the simulation here. I'm going to restart it. And I want to build this atom. So I'm going to add 3 protons to the nucleus, to the center. Notice, as I add protons, it's changing the element. The element is named above it. Only 1 proton means that the atom I'm talking about is hydrogen. If I add another proton, 2 protons is helium. If I add a third one, that's lithium, okay? So right now, I just built a lithium atom, but I'm not done yet, all right? Notice that my numbers are 3, 3, and positive 3, okay? So I'm not done. I need to have a mass number of 7. Well, I can't add more protons to get 7 because that's changing my element, all right? I can't change my element. I can't add any more protons. But I can add neutrons because neutrons also exist in the nucleus. So I'm going to keep adding neutrons until I get my mass number of 7. That's what I want, all right? That's what was given to me. So what I just did was I had to add 4 of these neutrons to get a total of 7, all right? So now these two numbers match what I had before. It's got 3 protons in the center, which is the number down here, and it's got a total of 7 particles, neutrons and protons combined in the center. That's what that number means, all right? And then this last number is the charge. Well, if I want a charge of 0, like I said before, I need to cancel out every proton with an electron. Well, how many protons do I have? I have 3. So that means I need to add 3 electrons. And you can see as I added the electrons, my charge went down to 0. Because now I have 1, 2, 3 negative electrons, And those canceled out my 1, 2, 3 positive protons. So now I have the atom that I was talking about here. Lithium looks like this. All right, so that's how you would build an atom. We'll be working on building atoms at the end of the week, but I just wanted you to visualize, okay, what's actually going on here. So let's do some examples. Let's go down here. Let's do fluorine. So fluorine is on the periodic table on the right side. It's up here, just chilling. And it has a mass number. It has a mass number of 19. Remember, this is the number of neutrons and protons combined. This bottom number is just my protons. All right. So I can fill that out right now. My number of protons is 9. How do I know? That number always tells me my number of protons. Well, if I want to find my number of neutrons, what do I do? Well, remember that this is my mass number. It's made up of my protons and neutrons. So 9 of my 19 particles in the nucleus are protons. So if 9 of my 19 are protons, how many of them must be neutrons? 10. All right? 10. You can figure that out by taking 19 and subtracting 9, and then you get 10. So that's how you find your neutrons. The top number minus the bottom number, that gives you the number of neutrons. All right, and lastly, my number of electrons. Remember, protons are positive, electrons are negative. Neutrons have no effect on charge whatsoever. So if my overall charge is supposed to be 0, okay, that means that all my protons were canceled out by electrons. So this is my charge. My charge is 0. All of my protons, all nine of them must have been canceled out by electrons. So if I have 9 protons and they all got canceled out, that must mean I had 9 electrons. Okay. Another way to write that is if I drew all my protons, so I got 9 total. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. I would need to add 9 electrons for them to all be canceled. So I've got my 9 protons up top and my 9 electrons on the bottom, and they all cancel out. So what's my overall net charge? It's going to be 0. All right. So based on this charge is going to tell you how many electrons you need to add or subtract from your protons to get the overall charge. So if you have an overall charge of 0, your number of protons will always equal your number of electrons. All right, let's do another. We got oxygen right here. So we have oxygen, and it has an atomic number of 8, which that represents my number of protons. It has a mass number of 16. Now remember, that is my number of protons and neutrons together. So if 8 of my 16 mass particles are protons, how many of them are going to be neutrons? Well, 16 minus 8 is 8. All right, so I've already got the 2 numbers done. The hard part is this number, okay? My charge is -2 or 2 minus. Sometimes we write the minus afterwards. That's just how scientists write it, but it just means -2. If I have a negative overall charge on this atom, would I have more negative particles or more positive particles? I would have more negative particles, okay? If it's got an overall charge that's negative, that means I'm going to have more negative than I do positive. How many more? 2 more, okay? That number tells you how many more negative particles I'm going to have than positive particles. Well, what are my negative particles? Electrons are my negative particles. Protons are my positive particles. If I have 2 more negative particles than I do positive particles, how many negative particles or electrons would I have? Well, what's 2 more than 8? That's just 10, okay? So I have 2 more electrons than I do protons, which gives me an overall net charge of 2, -2. Because remember, these cancel each other out. The 8 protons I have cancel out 8 of the electrons. So what am I left over with? I'm left over with 2 electrons, which have a negative charge. That's why my charge over here is -2. All right, and lastly, let's do these. They're both sodium. All right, Na stands for sodium. It is right here on the periodic table. They're both sodium, but notice they have different charges. Okay, that's important because it's going to determine something. So let's do these together. We got sodium here. How many protons does it have? Well, this number down here tells me my number of protons. I have 11. How many neutrons do I have? Well, remember, that top number is my number of protons and neutrons. If 11 of my 23 are protons, then how many do I have that are neutrons? Well, 23 minus 11 is 12, okay? So how many electrons do I have? Remember, because this atom is neutral, that means that all of my protons were canceled out by electrons. So I have the same amount of protons as I do electrons. Well, if I have the same amount of protons as I do electrons, how many electrons would I have? I would have 11, because these guys essentially canceled out their charge. The charge essentially canceled. So I have an overall charge of 0. Excuse me, I'm dying. Over here, we have a charge of positive 1. I just need some water. I don't know if I'm going to cut this out or not. I don't think I'm going to take the time to do that. You just have to listen to me drink. All right. Slurp juice. Good. So we got sodium, plus 1. How many protons does it have? It's got 11 protons. All right. Same as before. Up here, my mass number is the same. Okay. 23 minus 11 gives me my 12 neutrons. So far, my problem's the exact same. But what's different now is my number of, or my charge. My charge is different. I've got a positive charge now, a positive 1 charge. Well, I have to ask myself, if I have an overall positive charge, am I going to have more positive charges or more negative charges? I would have more positive charges. How many more? I'd have 1 more positive charge than I do negative charges. Well, I got to remind myself, which one of these is a positive charge? My protons are positive. My electrons are negative. So if I have 1 more positive charge than I do negative charges, how many electrons would I have? I would have 10, okay? Hear me out. I would have to have 1 more positive charge than I do negative charges. That's why I would have 10 electrons, all right? I know it seems confusing. You would think, well, why don't I add 1? Well, remember, electrons are negative. I need to have 1 more positive charge than I do negative charge. So 10 of my electrons canceled out 10 of my protons. What am I left over with? Well, 1 proton, and a proton is positive, and that's why I have an overall charge of plus 1. So when you look at your worksheet, you are met with a series of tables, okay? Let's just take a look at this. You got, let's do some together. Let's do helium here. The name of the element, He, well, that's helium. The atomic number. My atomic number is down here. It's that 2. Wait, what is the atomic number? That is my number of protons. What? You tell me that this column and this column are the exact same? Yes, okay? Your atomic number is your number of protons. They mean the same thing. What's my mass number? That's the top number. My mass number is 4. Now remember, the mass number is your number of neutrons and protons combined. So, how many neutrons would I have? If I have 2 protons, and my mass number is 4, that means 2 of my protons make up this 4. So how many neutrons must I be left with? I must be left with 2. Because remember, the protons and the neutrons together, when you add these 2 together, that makes up my mass. That's what that mass number means. All right. And lastly, what's my charge? Well, if it's not shown here, and it's not, then my overall charge is going to be 0. I draw a line through my zeros. You don't have to. Well, if my overall charge is 0, that must mean that my positive particles must cancel out my negative particles. Remember, your protons are positive, your electrons are negative. So if I have an overall charge of 0, that must mean that my protons are equal to my electrons, so I must have 2 electrons. All right? That one's challenging. So do as much of this as you can, all right? This is going to be due on Thursday, but do as much as you can. And if you struggle with the bottom ones, that's okay. I want you to at least get like the first half of this table and get familiar with that. The charge is the hardest part. Once you have the charge, what do you do with the electrons? We got to think, do I need more negative or more positive charges? And how many more? All right. If you need help, if you want some extra help, then just email me and I will be glad to help you. But I wanted to give you this as a resource in case you wanted it.